next quiz is Thursday. What? Chapter 4. Yeah. Of course, yeah. We're going to do a little review of that in a minute. Yep. I'm crazy. Last time we finished chapter 4, so the homework is due Thursday, and that's kind of like how I figure out where to put quizzes. A little extra motivation so you actually are staying on top of the homework.
Oh, you mean like due for all of the...
Again, let me say this again. So, a million years ago, but it's on the syllabus. The intermediate due dates are 2 classes after I finish lecturing on something that homework is due. It's not late until it's after the day of the test.
Okay.
But if you've caught on to this, if you haven't, I'll tell you this. How do I figure out when to put what quiz? I see what homework is due when, and I make a quiz on that homework when I feel like it. So the Chapter 4 homework is due Thursday to be on track. Does it mean you have to have it all done? No. But you should probably have looked at some of them in every section so you're ready for that. Yes? Yes. It'll be late, but it's not going to kill you. It'll be a lot more points than none. Yeah. So you can turn in section 1-1 homework on the day of the final.
And the missing homework that you put on the paper?
Yes.
That one, like, it's good, like, to turn into...
Yes. Again, you can turn in section 1-1 homework on the day of the final. You can turn in any homework you haven't turned in yet, anytime. The later it is, or the more that's late, the more it affects your grade. So if you have one section that you didn't do, and it's like a week late, that's not going to hurt you at all. If you have one section you turn in 7 weeks late, that'll hurt you. If you have a whole chapter you turn in a week late, that'll hurt you a bit. But it's going to be a lot better than having a 0 for that shit. The final's cumulative, so I'd like you guys to have motivation to keep doing homework because that's the best way to study. You like it? Yes.
Test 1 correction, what does that do?
Test 2.
Test 2.
So test and quiz corrections always do the day of the next test. So test 1 corrections, you can turn them in anytime you want to until test 2, and then you can turn them in after that, but then it's late and you get less points back.
But test 1 means it's to turn that.
No, the test and quiz corrections are always due the day of the next test. So like quiz 1, you could turn those corrections in, but they're late because they were due the day of the first test. Yes?
I know you said this a lot of times. Can you explain again how it gets affected if like you do well on your test correction or quiz correction?
So for example, the probability quiz doesn't work like this because the test is not covering probability. But the quiz we take on Thursday, let's say you didn't do the homework and you get a 60 on that quiz. Anybody tell me how many points you could get back if you did all the corrections? So say you get a 60. That's below an 80, so you can get 1 point for every 4 you missed. How many points did you miss? 40 divided by 4 is? You could get 10 points back. If you do all the corrections, get them all right. This is not new news, by the way. I love some of you guys are like, what? Yeah. All right. When did I say? First day. It's on the syllabus. But let's say you do the corrections and you get 5 points. So you get half the points. You with me? You didn't get all the corrections right, so now you had a 65. Then you take the test and you get an 85. Higher than the quiz grade. You with me?
Yeah.
And since you did corrections, I'm going to raise it, but since you got half of the corrections, I'm going to raise it halfway, and now your quiz grade becomes a 75. If you got all the corrections, I would take it all the way up to this. What? I do that to make it fair, because what happens if you miss a quiz legitimately? it gets replaced by the grade on your next test. So to make it fair for the people that were here actually taking the quiz, I want to do something similar. To be really honest, if you take a quiz, you are that much more prepared, so it kind of, you're getting a bonus already, but I just wanted it to be grade-wise, numerical. You get a, makes it fair.
And then how much points can you get back if you do above an 80%?
You get 5 points back max, up to 100. Because 80, how many points did you miss? 20 divided by 4 is? Holy shit. So I make it match at 80. But I say below 80, you're doing more work, so you get like a point for every 4 points below 80. So you get a little more points because you're doing more work.
And then for the probability quiz, you don't get to like.
Well, you can still do corrections. It's just, it's not on the next test, so it's not going to be connected like that. But this one will be on the next test. So this one will do like this. I like it. So why make corrections? Because you could get points back, and then you could get more points back. So short answer to that, kids, is do the freaking corrections and maybe get help. Right? There are several corrections I give back there. You get 0 points back, which means I don't give a shit what you do on the test. You're not going anywhere, right? Because you got none of them right. That doesn't make any sense, right? You can come see me and say, do these look okay? And I'll tell you which ones don't look okay, and then I'll help you work on them. All right. There's only so much that a person could do. Okay. And all right. Anything else about that before we move on? All right. So let's do a review. Oh,
I have another question.
yes.
72 I just have, can you read them how to set up the table?
Is this one of those about lottery or something?
I think it's.
Well, why not chapter 3? That's useful. 72. Oh yeah, perfect. Okay. So let me do a problem like that. All right. So say you buy a lottery ticket. It costs, let's say, $2. Cool. And let's say there's two prizes. There's a grand prize. There's one ticket. We'll give you the grand prize of $1,000. And then there's 3 tickets that will give you another the not so grand prize. Bless you. Bless you. $10. You guys with me? Okay. Like we're in the same room with you. Is that what you mean? And let's say there's a total of what you got, Chuck? Let's say they sell a total of 1,000 tickets. And then I ask you, what's your expected earnings? Right? And if it's negative, that means you can expect to lose money on average, which is the way most lotteries should be. Most casino games, in fact, 99.99% of the casino games, you have a negative expected value. Why does that make sense? Because who set up the casino game? The casino. And what's a casino in business to do? Make money. So sure, that one guy over there maybe just hit the mega jackpot and got $2 million. But then there's 3 million people that just spent $2. And so overall, the casino's like, take your $2 million. I don't give a shit. I just made $10 million over here. You guys kind of. So that's what expected value could be used for. How much to set an insurance premium at. To make sure that a lottery you set up will actually bring money into you overall. Okay, maybe. So, expected value is another name for mean. I need to set this up, like you said, set it up in a table. And let's see if you guys can get this. How many total outcomes are there in this game?
10.
No.
Unmodified You
I didn't mean to be so mean. No.
You mean like the
How many outcomes are there?
3,
3. What are they?
10, 1,000, and -2?
Sort of. I appreciate it. So there's 2 ways you can win, and then of course you could lose. I like it. And how much you have to pay to play? $2, and you're buying 1 ticket. So if you win the $1,000, how much money did you actually make? $9.98.
Oh,
What's the probability that you win the grand prize? How many total tickets were sold? 1,000. How many of them are for the grand prize? 1. So what's the probability you get the grand prize?
1,
Tell me as a fraction.
0, 1,000.
1 out of 1,000. Everybody with me? There's one way to win the grand prize out of 1,000 total things that could happen when you buy a ticket. Okay. What's something else that could happen?
8,
Small prize.
8.
Yeah, $8 because you got to pay $2, so you actually make 8 if you get the small prize. I'd still go for that. And what's the probability of winning the small prize?
1 out of 10.
No.
3 out.
3 ways to win it out of 1,000. So what happens if you buy a ticket you don't win? That means you actually did what? You lost how much? $2. How do I write that? I don't put 2. -2. That negative is flowing away from me as the player, right? So the person who puts this lottery together, they want this to end up being a negative number because that means it's flowing away from the person playing and to me, the lottery person. You guys follow a little bit now, okay? Maybe. And what's the probability of that? 996 tickets are worthless. Or, if you bought a lot of them, you can make a little fire and keep warm for a bit, but they're basically worthless. And now, how do you get the mean? How do you get the expected amount? Once you got the x's set up and you got the probabilities of those things, how do I get the mean? No? Multiply them. X times p of x, right? X p of x, and I sum that up, that's going to be the expected amount. So we get 998 out of 1,000. We get 24 out of 1,000. And then we get, oh shit, what is that? Negative 1894? Is that what that one is? No, it's 1892. You guys can check me on that.
Yeah. Negative 1992.
1990. Of course, Jeff. Come on, buddy. Give me a break. That was a good year. I heard about that year in a book. So now what's the expected value going to be? You can tell it's going to be negative, right? If you add all these things together. Let's see, what are you going to get? Negative 972? I don't know. When you add all those together? Yeah, negative 970? Is that what it is?
Yeah.
Okay. Over 1,000, which is negative 0.97. So on average, if I play this lottery over and over and over again, I can expect to lose 97 cents. Another way to look at this is, stay with me, kids. If you get 1,000 people to play this lottery, they each will lose this on average.
That's the mean, right?
That's the mean. That's the expected value. You guys with me? If I have 1,000 people play, they each will lose this, which means overall they've lost 970, which means I've made $970 if I'm the one running the lottery. So I'm paying out $1,030 in prizes, but I'm making $2,000 off of tickets. All right, maybe. So there's a couple problems like that. You just have to identify the numerical values, and you can put next to this is win, lose.
So is that like you're losing 97 cents?
On average. So you could look at it 2 ways. If one person, played this lottery multiple times, I would average a loss of 97 cents. over all the times I played. You with me? A little bit? Every time I play, how much money do I definitely lose before they even picked a winner? $2. So what that average is saying is, if you played a lot, maybe you'll win once or twice, but you will have lost so much other that you come out to an average of 97 cents lost for each time you played. You guys semi with me. This is what it means to be a gambler. Right? You're like, I can accept that. I'll try it because the possible payout is good enough. Maybe, depending on what your personality is like. And $2, I can handle that. Okay. So there's a couple problems like that in the homework. Anything else from the homework? Yes.
82.
Oh, well, there you go. Oh, that one. Oh, wait, here. Okay, I was looking at the wrong one. Oh, this is about the babies, the hearing loss. Okay.
Yeah.
By the way, on the quiz, I'm going to put the formulas on the quiz for you, okay? So you don't have to worry about a formula sheet yet. So let's see if this problem sounds familiar to anybody. Are you working today? Yeah. Wow. Babies, according to a recent article, the average number of babies born with a significant hearing loss is approximately 2 per 1,000 babies. Suppose that 1,000 babies from healthy baby nurseries are surveyed. Find the probability that exactly 2 babies, I don't know why I'm saying this, were born deaf. So you want to identify these things. 1,000 babies surveyed. So what's that go in for? Bless you. See again? N. What's P gonna be?
0.02.
Yeah, well, what is it gonna be? It's gonna be 2 out of 1,000, which is not 0.02, it's point tenths, hundredths, thousandths. Yeah, dude. So it's Q.
Q is 0.98.
Yeah. How'd they know that? Because these two have to make 1. And then the question says, find the probability that exactly 2 babies are born deaf. So what's that, of course? Well, probably the only one that's still blank, but why? It's probably exactly 2 born deaf. That's going to be X, because X represents the number of successes. Now, is a deaf baby a happy thing? No, but it's what I'm looking for in this problem. That's why we call it a success. So success has nothing to do with happy or sad. It just is. And now you can set that up, hopefully. Is that all right? Because a lot of people start that problem off wrong. You misidentify what it is. It's a binomial problem. It's what I call an NPQ problem. And then you're going to use this little dude here, right? N choose X, P to the X, Q to the N minus X. Maybe you're dying, poor little dude. Yes?
So X is always like what you would put in, like for example, you put that into, out of like 1,000 to get.
No. This specific problem,
It happens to be.
they just happened to line up. It didn't have to. I could have said what's probably that 3 babies are born. That would have still been 2. Because they told me the likelihood of a baby being born deaf is 2 out of 1,000.
Oh, okay.
Yeah. So be careful about coincidences.
So it's always how many successes that they're asking for?
The X is always how many successes they want. So it's a question. What's probably that 7? Oh, 7 is X. Yeah. We're going to do some more examples of those also. Anything else from homework before you get back into?
99 is a distribution something.
The chance of an IRS audit. That one?
Yeah, 99. I didn't have question.
for a tax return with over $25,000 in income is about 2% per year. We are interested in the expected number of adults a person with that income has in a 20-year period. Oh, expected number of audits. Assume each year is independent. Blah, blah, blah. Okay. Is there a certain part of that you have a question? Because there's A through F.
C.
Oh, okay. So very often in this book, they're going to ask you, identify the distribution. And they're going to have this. Can anybody tell me a type of distribution we've learned? Normal. Kick ass. So maybe I could have, so one example of what this could be is X follows a normal distribution with a mean and a standard deviation. What other kind of distribution have we learned? Oh, so that's a specific shape of a distribution, but what other kind of distribution have we learned? What's the title of section 4.3?
Binomial.
Binomial. So it could be a binomial. So it could be X is given by a binomial, and the important thing about a binomial is N and P. And then what's another one we just learned about last time? Yeah, I suck at charades. Uniform, right? Uniform distribution. Yes? Didn't we talked about that last time, right? I know it's a long time ago. So it could be uniform. And what's the important things to know about uniform is going to be the lowest to the highest. So from 2 to 7 or something, because that sets everything else up. So you'll see that question in a lot of places in this book. Yes?
What did you write next to the mean?
Oh, that's trying to be a standard deviation. And we know that. What are the two most important things to know about a normal distribution? Mean, standard deviation. What's the two most important things for a binomial? N and P. Well, I don't even need to know Q, because I can figure out Q if they give me P. And then for a uniform, it's going to be, what are the two sides? The lowest A, the highest B.
Are you going to form out questions like that?
No. But you got to be able to answer the book. And anything else from homework stuff?
And then when we say about a random variable of X, like in words, how do you describe it?
So I mean, what does X represent?
Yeah, so is a tax returns and without returns. Do we have percentage of tax returns?
So we are interested in the expected number of audits a person has. So X just is the number of audits. Because how many audits could a person have from 0 up to something? In a 20-year period, 0 up to 20. Yeah.
Okay.
So the random variable would just be the number of audits somebody could have. Yep. Okay. Anything else from homework stuff? Homework stuff. All right, so let's do a review real quick of uniform. And then I've got a little worksheet for you guys to try out. Ooh, cool. So if I had a uniform distribution from 11 to 19, so draw that distribution for me, showing the height. So uniform, of course, means what shape does it take on? Big old rectangle. Gotta love that shit. And we already talked a lot about how area is related to probability, and any question involving rectangles, I can calculate the probability is easy, because it's finding areas of rectangles. Kick ass, right? So I want to go from 11 to 19. So how tall is this going to be? And if this is supposed to represent probabilities, and the area is related to the probabilities, what should the total area be? What should the total area be? Well, what's the total probability of any situation? 1. I like it. Somebody was motioning me back there. 1. I didn't know if they went. So the answer is there. So how wide is this? 8. So how tall is got to be? So the answer is 1 when you multiply them. I love you guys. So you guys don't like to talk, so you like. Right. Does everybody get that? Do you see that? Yes.
Why is it 1 out of 8?
Okay. So it's 8 wide, right?
Oh, okay.
And the area's got to be 1. What do I multiply a number by to make it 1? It's reciprocal. Yeah, coolness. So you could really say to me, Jeff, you wouldn't multiply 8 by 7. You would divide 8 by 8. All right, 8 divided by 8 is 8 times 1/8. Bam. There is no division. Oh shit, there is no division. There is no division. There's only multiplication by the reciprocal. But we can look at it as division and it's all good. All right. I don't mean to get semi-deep. So, if I ask you now, find the probability that it's from, what you got, Jeff? 12 up to 17. How would you do that? Yes, ma'am. Say again? No. I see what you're trying to do. I can't change that. I'm asking a question now about something inside of this. So how would I draw that over here? It'd go from 12 to 17, right? What's the area of this shape? 5 times 1/8, so 5/8. If I'm given this and I ask a question, that doesn't somehow go and change this. Oh yeah, the kids are age 11 and 19. Well, what's probably 12 to 17 and now all the 11-year-olds just like leave or something. No, it's still the same situation. Are you guys with me? Just because I ask a question, I can't change something they told me about the general situation. But that's definitely going to be 5 times 1/8. So 5/8. What's the probability x is less than 18?
Seven out of 8.
Sure. So let's see. So if I draw it real quick again, bam, 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 11, 19, 1/8. Less than 18 would be this. And of course, how wide is that? 7. 7 times 8. 7 times 1/8. And of course, you can make this into decimals, right? So this will be 0.625 up here. And this will be whatever the hell it is. What is it? 0.7. You can do it, Jeff. Can you do it, Jeff? Is that 0.7? Aren't you tired? Let me see. Oh, it's 875. Come on, dude. Wake up. Yes?
Dude, so for the test or quiz, whatever, do we have to do it into the decimal or do you want to or you don't?
Oh, definitely. So I'm trying, if you've noticed, every time we've done one of these probability things, it's always like at least 4 places. Mm-hmm. And that's because we're going to use a chart pretty soon where it gives me all these probabilities to 4 decimal places. So I just wanted us to get used to that. These only go out, the next decimal is a 0, so who gives a shit? You don't have to do that. Okay, maybe. Is everybody cool with that? That's all uniform probability is it can be represented as a rectangle visually. Since probabilities are related to areas, probability question should be easy. What about this one? What's the probability that x equals 15?
Equal 15.
Yeah. So what's that look like? X equals 15. That would just be a line at 15. What's the area of a line? 0. This is where I talked a little bit about iota, I think. Right, not iota bank, but iota. It's a Greek letter. You don't have to know that. And again, I don't have to go into any weird shit. It's just the probability answer is related to the area of what it's talking about. Area of a line is 0. Yes? That's a 7, yeah. Because less than 18, it would be from 11 to 18, that's 7 wide. Okay, sweet. I got you. If it was a 2, I would need some help. Yes?
Could you explain why? I mean, I get what you're doing, but like I don't get why you multiply distance by like 1/8. Like why do you do that? Like, just so it makes sense.
Alright, so when I draw this, so for example, 12 to 17, what shape have I just made? A rectangle. How do I find the area of any rectangle? It's the length times the width. That's it.
The probability is synonymous with the area.
Yeah, and that's why I did the whole dartboard thing and all that stuff. Yeah, if I make the complete area 1, any sub little area is going to be related to the probability of that area. So it's probably, I would get in the bullseye of a dartboard if I'm just throwing it over my shoulder, is related to how big that area is. Yeah, I like it. It's a wonderful physical meaning, and we use it mathematically. That's so beautiful. Now, what am I not going to give you? I'm not going to give you that. And that's what you make so that the thing is valid. How do I make this valid? I make the area 1, so that's why that's got to be 1/8. Like it. Yes?
Yeah.
If you have a probability distribution